Hey everybody, I just thought I'd do a quick video to talk about a little bit about the lab this week. We're sort of taking what we've learned in Python and trying to apply it to the principles of discrete mathematics. And so we're starting with this sort of counting combination sort of theory stuff. And I think where we'll really relate to what we've talked about before are those truth tables, but we'll get to that in a second. The first idea is just that, to basically add two things together, right? If you wanted to count a quantity and then add another quantity, you could just, do essentially two loops, but back to back. And so here I could, for instance, say for friend in male, and then print friend, right? So that'll print all the friends in the male category here. Obviously, these are characters from the sitcom Friends. All of the male friends, and then we could print, for friend in female, and we could print our friend here, friend. Right? This will give us sort of the sum of these two groups, right? So we've got sort of all of them added together. Obviously, 6 friends, that sort of makes sense. 3 in one group, 3 in the other group, we're sort of adding them together because the loops are consecutive. But if you want to start showing combinations, right, then all of a sudden you go to something different. Now, when we think of nested loops, at least for me, I always think immediately of tabular data. And I start to sort of picture how I would represent that data. So 2 loops nested is fairly easier. You just get a table. Once you get to 3 loops, suddenly it's like sort of a cube of data. But for this, it's much easier to just sort of think of it as I'm getting every possible combination of one group and another. So here, I'm going to tab this in, get rid of this print statement because we no longer need it. And now, suddenly I have a name conflict here, right? So we'll have to say, F friend and male friend. And so here we could possibly talk about every possible coupling between all of the different friends, right? For much of the show's run, people didn't know who was going to be with who. And of course, they had episodes where they tried to sort of flip who was going to pair with who. And so, let's see what actually happens. So here's every possible combination that you could have, excluding any sort of same-sex relationships, which totally could have happened, but just didn't happen to with these characters. In which case, we just have to do that in a slightly different way. But right now, I can print out, first off, proper indentation. This is Python. I can print out mFriend. Oops. My keyboard is elevated, and that's why I cannot hit my keys the way I normally would. So we could print out mFriend, maybe the keyword and. I'm going to get a space at the end of that anyway, because of my use of commas, and then friend. And so this is every possible combination, just because I've nested these loops. And so with 3 by 3, you can imagine there's now 9 different possibilities, right? I guess I didn't need that first space either because of my comma there. So here we go. Okay, let's ignore the fact that the first 2 are siblings. It's obviously a little not acceptable, but Ross and Monica, Ross and Rachel, Ross and Phoebe. Also, Chandler and Monica, Chandler and Rachel, Chandler and Phoebe. Joy and Monica, Joy and Rachel, Joy and Phoebe. You can kind of see how that every possible combination is really just a reflection of multiplication, right? The product of these 2 groups. If you're just trying to sort of multiply them together, you can sort of see how the combinations work. And so here's every possible combination of coupling. So now what if we were to take this and scrap it and start doing something that is a little bit more similar to what we've talked about before? Let's say that I want to represent the truth table for something simple. Let's do A and B, right? Here I'm going to use sort of a more Python word specific than those symbols I don't have access to in PyCharm. And so I could do the truth table for A and B simply by, for, let's say A in range and My range here, I'm going to keep it really simple. I'm going to use 0 to represent false, 1 to represent true, which of course you can do in your assignment as well. And so here I want to do the range from 0 to 2, remembering that the 2 in that range is not going to be included. So this is just going to do 2 options, 0 and 1, right? So, so with the 0 and 1, I'll have sort of every possible version of false and every possible version of true. But I want to get all the different combinations for the truth table. So here I can say for B in range 0, 2. And now inside of this loop, I have essentially access to every possible combination of A and B possible. Now, because we're talking about true and false, there's only the 2 options, 0 and 1. But obviously, if there were more options, you could do different ranges. And you'll see that in the exploration page where, that second number in could be any possible number, and you'll get every possible combination between those 2 ranges. But for right now, every possible combination is true or false. So this is exactly what I want. So here I'm just going to print out, let's print out the value of A, along with a little, prompt, or label, I suppose I should say. We'll do the value of B, put a space there, and so it's double spaced, and then B, and then we can put in the value of A and B. Yeah, just do a standard range. And then here, what I'm actually going to print out is just the logical value, A and B, which looks like A and B in Python. So there we go. We can do that, and we will now get the truth table for AND, right? Which you can see here sort of aligns with everything we've done. Here's every possible combination of A's and B's. And I can see that the A and B, the only time that's true is when A and B are both true. So thinking about nesting loops as a way of getting every possible combination can be kind of interesting, as opposed to thinking tabular data. And you can also make it a lot more complex, right? What if I wanted to do A and B or C? Well, now I have a third option. That third option can also either be true or false. I think you know where we're going with this, right? For C in range 0 to 2. Now I'm nesting 3 in. In fact, let's even make it even more complex. Or D. A and B or C or D, right? Keep nesting for D in range. In other words, I'm no longer thinking about how I would represent this data, in terms of tabular data. Now I'm just saying, yeah, I know that as I nest these things, however deeply I nest them, I'm going to get every possible combination of A, B, C, and D across all of their true and false values. And so then I can just arrange it. And here, unfortunately, we're printing out a lot more now. We're going to do, let's see here, C colon, stay consistent, comma, C, and space D colon, comma, D. And then I think for this one, I'm just going to do, so there's just the entire sentence. Actually, no, let's do it. We'll say A and B or C or D, colon. And let's even put a little extra space and some dashes here so we can very clearly see what we're supposed to be seeing. And so now my prompt is different. That means also my logical expression is going to need to be different. So much so I'm actually going to put in a bunch of parentheses just so that I know I'm doing this right. And it was or C or D. Literally, I am just like, that expression is the exact, prepositional expression that you would see in the work that we were doing. And so here I can get sort of every possible combination, the truth table for this entire thing, assuming I haven't missed a colon somewhere or a parenthesis somewhere. But here we go. You can see A sort of does all zeros that all ones, right? B, it's going to be 4, 4, 4, 4. C is 2, 2, 2, and 2. D flips back and forth, 0, 1, 0, 1, 0, 1. That's going to give us every single possible combination of A's, B's, C's, and D's, right? And here I can see the truth table for my little expression here. Basically, it's false whenever whenever you just have these two have to be false, really, and then because the and is false more often. So you can see how that sort of works out and sort of plays out, and you can get every possible combination with the truth table for that statement. So that's what we're talking about this week, different combinations of things. Apologies for the fact that this is all so very long. There we go. Now I can actually see it all on one screen at one time. But that's what we're talking about this week. It's using nested loops to look at the different possible combinations of options and actually trying to build truth tables from scratch. So if you have any questions, send me a message via Canvas. Have a good week.